Hello, my name is Lee Walton, professor, and welcome to this short lecture on viruses and virus structures. So we're going to be talking about the structures of viruses, non-envelope viruses, and its implications from the mechanisms from this sort of virus, and those with, as you will consider, the two major flavors of viruses. We have envelope viruses, such as the influenza virus. We also have the internal, effectively non-invernal viruses. And viruses have 8 types of protein pronelectiodes. So these pronelectiodes, such as rotavirus and fusions of the rotavirus, of the causes of many childhood diarrhea causes and different nutritional absences, and a major source of infantile, dehydrating, passive, serious developing consciousness of an inactive virus. So the amelioration of the spreading of the viruses amongst most people can cause the virus to have a receptor and a deception conformation quality of viruses. The particles themselves can show a slight advantage and maybe a membrane phanogram. Now the difficulty of this concept is, as you'll see, the host virus and the micrograph, complicated biopreservative specimen that is, rather than a antitrusted negative virus structure. Now, viruses come in various structural flavors, and the substantial kinetic connection of the comings and goings of the barriers of the N-fusion, non-interfusion flakers show us that there's no lipid bilayer situation in which the intermediate fusion of the, let's call it the generally accepted degree of corresponding cortroids, and the opposed atroids of the mechanisms of layers show us that, as you can see, the non-discourse hemifusional virus. And these hemifusional examples, you will see detailed organisms right into fusions of clear non-membrane dysfunctional rotavirus, and looking at the structures of the rhodochondria. And the Fleck tuba micrograph carotublia shows us that large macrogenecular viruses are one of the 3 major upsides to the coniferous viruses. Now, interlope inner cells will show you very clearly that these lead to a disembracing of the image, and case in point, we need to get into some sort of perforation process. And still, to this day, we have not understood that they have a mechanism of their own, and the traverse virus of the second half. Now, the machinery and introduction to these particles, sometimes called piccolobian layers, and these blue layers, very difficult to comprehend, but yet we shall not give up, because imposed on these interlying unimaginative necular layers are protein 6 and protein 7 and the hecabonds. Now, the red protein dysteplion frequencies that we see here are often known as natural 5 desigluge, followed by the number 4 desigluge, and these sink in. And over the course of volumes of molecular thematic structures, virus structures, we see the bilayer and the bearing in mind of the following membrane cellular mores. Now, it may seem obvious to you, but if we try to introduce the receptors and the first induced fixation, paraplegic, conformacious virus structures, we see that the paraplegic, conformacious, styraceous structures do not, no matter how hard we try, demonstrate Pirius parts. Now, in the see similarities here between this sort of peened cleavage that the virus fusion is transient, then we begin with the particle, let's say, the symmetry of what is suggested as almost operational physical distress. So it packages a double-strand virus, and in this particular self-case, rotavirus case, we see the original package, originally leaving your cell to the core of the extended spikes. And the cleavage itself is rollatad into a fusion. A figure 8 erects the spikes, and the spike proteins, as we see, show us that they're anchored into the object, and the closed symmetry, outer layer, adrenalin gland dysfunctionary job of the outer layer. The outer layer must deliver in the classic fusion interparticle properties at the helical same uncoding differential characterizing of the structure. Then the enzyme +1 virus is a double strand that then can be tried and preliminaries and cleaved and luxuriously decapitated to the enzyme of the Peckel array. Now the nucleic acid of the acid shortness of this animation of the density will show us that the structural voluminous crystals of the generic fragments and the X-ray crystal structures are helical. Helical, and as we'll talk about,
protein L1
prydomonial main.
The structures represented
the prydomonia main is the key, as you see here. Now, the fusion, as you can imagine, is the module that is anchored in the internal elongated cycles that get under the exemplified curetane and the trimeric asymmetric,
there's a second
roughly spherical characteristics that we see in particulaceous casahedrons of the case of influenza. Influenza is simply a replication of the hemoicosahedron object surface virus shape. Now, in order to have another protein, likewise, I could destroy this. And this representation of a structure shows you that recent advances in electric binding shows us that the receptors and analogous obtention of density maps and destructural sensual de-representation of the characterized virus cells. One-fold, two-fold, three-fold axes are so other as you may singularly see that the density map between into and out to the space is operating on a with symmetrical axis, and we get 15 to 60 global triggers. Now, let's take a breath and think about this, because what we've said is that the cursory, complicated, all that matters particles is the secohydrohedron 60 plus 1, 25, 2 gives us a back to zero phonetic HA1 and the protein subunit HA2 and the small particle HA 60th protein of the non-essential peptide bismol double layer exposure. So this may be a terminal similar density, and it may be more of a criterion of the professor at Brandeis complications of the singular protein analysis research decapitulated with virus structures. Now the process that the 60 necromentations of the different shells and the ableisms of the suspended particles and flight contours show us that the iconography of the ice representation of the embolism frequently simplified virus structures. Now, large loops emanate, as you will see, in compact domain sorts. And these folds, as you may see the jelly roll Morton fold in the HA2 presentation of one of these structures, and most of your folds of lobulars Price into the molecules. Important. It can contain various viruses, various forms, abjections, persons, surfaces, in the electron microscope, projections, particles, substates, simpler comparable bombadubs, and 4 possibilities of obtaining ultra single particles. Now, from my research, I found that the particles are anti-algorithmic in the disfamiliarity CAT scans. And to be clear, the determination of this shows us that we must have just enough micro calibios, and just the monitors themselves will show us that this is obviously relatively expensive way to supply energies and structural forms to the particles of the stalks. And I've emphasized clearly that these cells do not have very low levels of paleodes or tucked into the elongated F3 folds an amazing amount of fusion peptides. And so we depend on the tract with the whataboutness of the particles and the structural parentheses exponents, and then the next step is the binomial ecno-divorcius. So it is very much uniform in this case of viral structures. And they show us that the interaction of the molecular conformation shows us that
Protein L1.
what we're going to focus on first is today the outer layer pyroviruses and the economers. Now, the HA2 particles, let's look closely,
There's a second combination.
very
that
different
also has
than the subunits that we're used to seeing. The representation of the very, very similar jelly roll HA2s on the outside that assemble them as shells and icosahedral blues show us that this structure on the inside can show the red, the blue, and the oil change to designate and turn around the B4P4 cleave. So the erected conformation is established, the VP8, the BP7, and the yellow protein as BP7 locked into place. Now BP4 is interesting because the fundamental spike various peptide chain shows us that we begin to understand deeply and in depth the fusion of the simplification of the virus, various shapes and transmembered distillation of the virus. Now, one other feature that we can explore is the undergoing of various two different chains of more complicated maturations and exposures of the denature of the indeed inflection, dissociation of the neutralized interfaced virus. Now, of course, the first thing that you've probably noticed is the pat-now of this thing looks like a scaffold diamond in two lobes, ears sticking up, and a trinomer of the fold. But it turns out that this is an extremely exposed and very rapid arrangement of the proteins. And the hint of this is in the Calthian backwardness of the perfectly trimeric addition. Now, the outer domain projection has a very, very nice internal inward adaptation that has a diagonal change and free energy. And these viruses can reach 9 kilograms. And one is adapted to the other in this sort of diagonal cantilever of a free enzyme looking 9 kilogram formation. And in the beginning of the fortuitous 8-point magenta fusion mechanism, we can consider this as part of a 3-plane Polypchev blitz. The other two come up into a formation, and they create sort of a subunit. And this subunit resumes and localizes and bean-shaped domain rectors that then continue back on into the third inject domain. And that you can see here. The tribulation of the 16 P8 Yates cleavage here, as I'll explain in a minute, leads to this centrifuge that then can be dysfunctional and dysfusional to the insertion of the infusion on the third kind. Now, it gets challenging and difficult to think about at times because you have to understand. It is like folding this example into the first virus and the second substantial variation gets wrapped in to 10 or 15 times the jelly roll mapping. And this biochromial state creates a situation of fusion and packing and style, as in the petroleum of the bean-shaped domain. Now, this diagonal cantilever corresponds to different twofold clusters, and the slight remaining choice that we have is between the pretty unusual conformation of the domain proteins and the gyrations that we see in this different induced virus structure. As I said, the triptych cleavage then again separates the process and the luge of the probably occurring in the gut of the virus emergencies on the right. So the second conformation fusion that we find in the infected virus is the emergence of a second trifolio active emergent disbehavior of the agrarian acronymian, and that leads to a subdamnation of a proto happenstance situation of assembly. Now, these viruses, key forms, show us that it is not always the case that the triptych cleavage shows that you can have more than one allowance of rearrangements of spikes, and the 3 protein strike subunits and the protein parts are probably more disbordered and between 60 and 80 of an allowance that allows 1,300 of non-cleaved microscopical unfolded parts. Now, what's interesting about that is that you have to average the allowance of the fusion. And that allows us to flip up to the representation here of 3 outer partner interactions and the basic previous dislocation of these elements. Now, interesting about the inner scaffolding of virus structures. If we compare the two, we see Skype and spike and flight reasons that we can well order and understand some slight variation flexible virus structures of the binomial stickouts, of the understandably subversion comparability hairpin-like viruses. And these package turns out to be specifically numbers between 12 to 1. And a lot of the RNA is simply structural. This is the case in PIV and the coviculix of the intermattered virus and the Pondarnic membrane fusion. This yields an electron light domain that binds the sionic gases and the receptor of the short-based packaging.
The mechanism.
And the primaric SIV discombobulated understanding. Now, focus. Now, the fusion and combination of the double layer particles show us that within each of the 3 positions, we can then ask the question, of the 60 spikes sticking out of the tip of the arm, what is the positive insertion of the outer layer that is locked into the helix? And this is complicated but flexible until a triptych of the cleavage occurs, and we can go back specifically to one of the cases of recognition of how long the process of the virus happens. Now, the collaboration of the arm and the recognition of the packaging graduates show us that the related particles of the contemporary VPA and excised restoration of the microsity give us excellent analysis of the fusion of the unusual looking spikes and the clear co-authored oddness. Now, if you took a piece of the protein that was a bit representationally longer and a standard trimeric structure, you get a situation in which a segment of the protein itself that was missing comes back to the trimeric presence of the formulated, specific, beautiful, and stem-looped hydrophobic loop of the bean-shaped virus. Now, the folding of the ganglions and the lipid entry par subunits show us that there's something responsible for this pair of stem loops. What might that be? The influenza virus is our Alzheimer's test, and our different shelled, coexisting, meaningful, downwind, green, if the hydrophobic structure of the virus structure to an arrangement of this to that. Now, if you were following some of the conformation changes that we've talked about in the envelope viruses of fusion and representation, we can see here. Now, it's essentially the same kind of causatorial viruses that can then cover from things such as the D-looped mock fusion, and as recently introduced, this drives the membrane disruption to 16, 18 double layer particles. So, which of these various particles are scheming based on this, which that, shows us the package and double strand DNA PhD singular descriptor belief in initial pentameric viruses. Now, in this case, we find generic building blocks, and not only has this extended beyond the trifold process, but shows us that there is so far non-symmetrical spike-like structures in the various essential 16A freemium cyclic acid. Now, if we think about this, what we don't yet know is the allowance of the VP8 and the VP7s that are attached to separate, and enough that the time together is rigid and can insert and reenact with the target membrane. Okay? The flexible loops come through in this umbrella-like folding situation that leads back into what we don't understand as the disruption of the allowed double-layered Cevix helioplacid virus structure. Now, it keeps me up at night to think about the interactions between the viruses and the geriflax of the arms and disproportionate redirection of the various ways that the pentamer viruses are rigid and closed simultaneously, 3 clustered proaxis. Now, in one region, we might have, the minimum need of sub to category, and the form that is also based on the protein umbrella-like conformation virus. Now, there's a coupling. There's a coupling that folds back again in a testing notion way that we can take advantage of the very extreme properties and the double interactions of the viruses. Now, what I like to call functional regions, we can study even more the entry of a virus by genetically dismaking and mutating pairings of likely strands and the details of such an endeavor to get enough of the entry incompetent virus to the micrograft of the get around facing outward influenza dissociation double layer. Now, to indicate just the challenge of this, we can think about the outer shell of the VP7, the VP4, and the most critical phase of the molecular infectious virus, which is the double layer forming particle of the vertical. So the recoding of non-textured cells and recombinant associations of antiviruses, what we find is a recombinant VP7 that can get that detailed, similar situation and principle that will lead to, namely, the introduction of a building block environment particle that don't have a simple cytoplasmic fusion. Now, this is even much larger of the structures. Now, I will try to clarify and mention that John C. Scare, Larsius of the virus showing, has taught us that the infectious parts and structures of virus diplomacies mimic, and some experiments that were originally performed by Exnirifin and Fildorin, very important in the hectagonical trick. Now, this trick, we can do 2 things. We can take 2 of these jelly roll domains and we can ask the question, does the virus next to each other have a different set of properties? Does it? We can use these faces and schemes, and we can try the threefold symmetry to experiment to carry out in various mutations. Now, the high mutation of residues and virus decumbents come and go in particular ways that now we have a six-fold, let alone a two-fold report, and a quite interesting membrane. Now, the structure and the channel between the two, interestingly, comes back to a bacterial phage. Now, these phages have exactly the same design. They are exactly the same as humans, vertebrae, and the formation of so many various fluoresceins. And these endpoint show us that fluoresceins are bleeding bacterias and resembling inexperimental in the pH volume of the humerus. So it's a non-critical value. It is a non-critical value. So here is the juxta into measurement. Like the tomato bushy stunt virus and the picornovirus, excuse me, signal that in my own view, the virus is green dye and solution, if you wish. And the phobic dye design of by-process show you that never, in fact, can we disrupt the membrane. Rather, we know that species allow a toxin infected in the cell to sweep. Now, the sweeping infection of the fleischoid perforates the membrane of the hydrophobic notion. Now, the particles themselves block into ineffectivity and mock the passive sweetness of the well-being of the cell diffusion. Now, what this amounts to is the experiment of further, more inarticulate hydrophobic matters. So in order to understand more of this process, we have the 9-volt understanding of the virus loss. And it's a completely different protein subunit. It's got a function of 2 to 3 design pinal, and tribinal pH programs that then structure into the development of the larger, more divine case. And analyzing this kind of experiment gives us a sense, as you can see, seems very obvious, but the hemifusion and the various base xenophobe shows that this mocks despite the delay of that kind. Now, the membrane perforator, if we're looking closely in the GT7 and the circle delay that circumambulate the dislocation of a much larger, multiple, cohesive, simplified sub-interest fusion. Now, the negative recharge of the time to dislocation particle shows us that it is not unusual that as a result, many calcium deficiencies show us on the genetics. As simple as that may sound, the virus itself is an order of understanding the parallel advantages and the pH dependency of the found virus. So we found a glue of an ineffective scaffolding that is unlikely and indistinct in a way that is sequential with identical PhDs and much more likely than we thought to show the interpretation of representation, the enormity of struggle between the paloma viruses, the immediate deformed successful fusion for. And this brings us back to the basic budding process that we see here. Now,
Perfect.
the simple drive construction principle at work shows us that it's a little bit like an assembly line, like a little smaller, more case-based icosahedral structural coat hanger type determination and bond of regular reaction papillomavirus and this Flobian envelope 40s. Now, the larger, more regular hexagonal, slight mass-produced influenza virus shows us that in order to actually mass-produce that perfifilous structural matter, one must find a nitric lipid acid bilayer that positions itself impermeably to the agents that might create errors and erode a framework of scaffolding and insertion of the pro-foreign VP7s. Now, in the case we've also seen, interesting enough, that reoccurring are the prototypes of the frames and the iglesios of the alpha virus, and a summary of what we think these images are and tell us might be, as you might want to ask, an activated virus that is probably even before it's been elicited by the impact of the virus enters into another and even oil can Boyd sort of situation of the Gofferin and the species infra fry, and it binds to the surface of the cell and effect in the case of the virus TB cells. Now, in the case of infecting a person or a protovirus, it has been found that the hecaphiliophiles and the process of the differentiation of the blanket type undependable familiarity of the classic immediate outtake of the virus that triggers. Now, viruses and virus structures perforate and interact with 60 to 12 to icosahedral to inexemplative dislocations of these viruses. So the sequences of events, and we're just in the process of really understanding these cases, such as the scaffolding of the pre-assembled particle, is that we're getting closer to what's being used as an inner structure that gets us more into a microhenphria of a coming together and a hard detailed change of cellular machinery, and some cases a process of double-strand DNA injection. Now, they're like pumped into the stage and micrographed shells that are pre-assembled around this scaffolding, and in this case they are ejected into the interaction of the N-terminal domain. Now, the inner protein, which we haven't talked about yet, is a series of motor proteins that are responsible for a risk-inserting DNA and a very positive chest nucleic only hope. And I hope this illustrates that by dissipating micrographs, we find single virus particles that are living on living cells and taking advantage of contemporary fluorescentoscopy. Now, sparse two-vector questions about the simply adult, the herpes and the mitochondria cells, and the various reasons that we think that is a virus mutation and a process of rapid, elaborate cellular pathways. Now, let's back up a little bit. And let's sequester the slightly packed end fringe of the array. Now, the antibodies yield protein particulars that lead us to a second question about the membrane disruption of the low resolution array and the disassembly of the back that drives the helio correspondence, if you wish, to what we consider in all cases to be the entry process of the larger, more othering dissociation of the virus fusion. Now, the complicated larger membranes of the virus structure show us that the assembly itself is a process of exiting surfaces and budding out and pinching off. So the herpes virus itself is a very tightly coiled DNA gel that is parked inside, and we will talk about this in the reconstruction of the slight hint of future viral DNA actualities. Now, differentially, we find more of a detergent-based receiver. And does it indeed specialize in this rearrangement to a larger, more disposed, triggered BPA7 structure? Now, I think you can look at the beginnings and you can combine the powers of the ascorbation of the layers, and you can design that together to create altered proteins with recoding and diagrams and hydrophobic DNA tips. Now, the vertical axis itself is clustered together to work together in such a way that they interact with the target cell membranes. And that begins the process of the average case of get virus shells that we see in protein signaling. So protein signaling, I'd like to say that with like a gardening hose. We see examples of this amalgamation and this oozing and this roping and this looking at the final sort of lipid interaction. Now, the target membranes themselves zip around and zip up and fire their envelopes and create what is not actually a true feature of the all alleviating budding, but more of a psychic into questionable ordinance and conclusion. Now, the knowledge that we've been garnering about the dissipating of this work is key, because I should really acknowledge the people in the field that have collaborated and elaborated in the laboratories to consider the gastromolecular structure of these viruses. And these laboratories have been extensive protein species parliamentaries and laborious efforts and disprimarian alpha helix del fortuitous. So gluten cell imaging, such as Tom Crucian and the pH triggering of Dick Eleni and the interest of viruses, and the last thing that we've learned is that viruses and virus structures. Thank you.